Folks, this is video number 36 for the playlist that is devoted to 3D Experience CATIA about the generative shape design application. I'll be talking about the circle icon. So when you're in generative shape design and you select the wireframe tab, you have the opportunity to make circle. There is a pull-up menu, and one of the items is circle. And when you click on circle, this thing pops up. This dialog box pops up, and there's a pull-down menu here that you have several options for doing different things. So we're going to try to do one of each of these. The first one is center and radius. Okay, so let's go to 3D Experience. Here's the generative shape design application. We can do these things because a circle is a planar curve. We can do the circle on any plane in space or any planar face, or just to make it simpler, I'm going to do it on the, for example, XY plane. That makes absolutely no difference. Okay. Keep in mind that we don't want to draw a sketch. We don't want to do something like that and then exit and say this is a circle. There's nothing wrong with that, but that's really not the point of what we are trying to do. So let me delete this. Okay. So select the wireframe tab. Here is the pull-up menu. There's a circle. And the first one is going to be center and radius. Okay, center and radius. Now, notice that you have to take a center, so a point. Now, I did not create a point, but that being the case, I can either get out and create a point on the XY plane, because I'm going to be drawing this thing on the XY plane, or you can do it right here. It says create a point. And I'm going to do that, for example, by maybe coordinates 50 or 30. There we are. And show this one up down 100. So we created a point right there. So we created the point, and the radius, we give it, for example, 6, or is that 70? Now, notice that we can't close this thing because it's saying that, okay, where is the support? In what plane does this thing lie? So now I have to go and select my plane. If I want this thing to be done in the XY plane, and that's really what I want, then I'm going to draw it. Now notice that there's something pops up, but this is the issue of graphics and maybe my computer, I'm not sure. And right now, it's not the full circle. The full circle looks like that. There we are. The circle is drawn here. You can see that. Or if you double click on it, you can do a portion of a circle. For example, you can do 75-degree sector. So this is an arc of a circle that subtends 75 degrees. Okay, so we did the first case. All right, so let me delete this. Let's go back to the circle. Center and radius we did. Now we're going to do center and a point. Okay, that being the case, you know what I'm going to do? I'm going to cancel that on this XY plane. I will on the XY plane, I create 2 points. So for example, on the plane, this is the XY plane, 1 point like that, another point on the same plane, XY plane, another point like that. Okay, now we're going to go click on the circle and we use the second option, which is center and a point. So for example, we can select this center as the center, this as a point, and once again, it says, where is the support? Because a center and a point does not give you the circle uniquely unless you tell me in what plane it lies. So for example, I'm going to select the XY plane, and this goes between 0 and 75. If you want the full circle, it's right here. If you want a sector of it, for example, I don't know, 75 degree I did before. There we are. Now, let's check something here. Suppose you go and say, you know what, I want this thing to be not on the XY plane, but on a plane. Let me clear this thing. Okay, let me select a different plane. For example, YZ plane. It's going to say, I can't do that because in order for you to be able to draw the circle with this center and that a point of it, these points must be on that plane that you're picking. That's why it's not working. Good. So this is a second option. I'm going to delete this. Let's see what else you have to do. I already have 2 points here in case I need. So we go to a circle. Once again, third option, 3 points. Now I already have 2 points. The third point, well, one of them I'm going to select this, the other one I'm going to select that. The third point, I didn't make it, so I can make it on the fly right here on the XY plane. There's the third point. Okay, notice that what it did, it actually put an arc between these 3 points. Now, it did not ask me for a support because you know that these 3 must be in the same plane, and in this case, XY plane. If you want the full circles like that, if you want an arc, this is the complement. This is the through the 3 points, and this is the complement of it on the other side. Very good. Okay, let me delete this. And by the way, notice that if you do it, if you create these points on the fly, they won't appear on the, you can use it, but they won't appear as a point in the space, okay? These two are created using the point icon. So let me go ahead and go to circle, go center and axis. For the axis, I don't have a direction here, so let me go ahead and just select some default, for example, Z-axis. Okay, then it says, what is the point? Now that point is not going to be on the circle. It's going to be a point that when you drop a perpendicular from that point to that axis, which is Z-axis, is going to give you the center. So if I select this, notice that it drops a perpendicular to the Z-axis. It ends up with that location at the center of the circle, and basically makes a circle. Okay, this point is not a point on the circle. By the way, here's the radius. You can change this thing from radius to diameter. You give it diameter, but it's okay. And you can make it full circle, etc. Good. Let's actually do something. So suppose that I draw a line on that plane, like so. Exit. Okay. Let's try it now. So we go circle. Using center and axis. So for the axis, we select this direction. For the point, we select, for example, this point. What happens is that it drops perpendicular to that direction, whatever the location of the intersection is. That point here is going to be the center of the circle. And of course, this is going to be the radius. All right. That's good. Let's get through some of these. I'll leave that line alone. Delete this. Okay. Let's go to the next one. All the stuff that I've done in creating these circles, I happened to select a support, which was a planar face or a plane. Some of these things, in fact, most of them can be generalized to be done on a surface that is actually has a curvature in it. So I'm going to go through some of them and repeat them with curvature. On that horizontal plane, I will sketch. I'll do a spline here. All right. So I'll do a spline, perhaps something like that. exit, and I would like to. I didn't draw this thing the way I want it, so I'm going to change this. Change the support of this. So I'm going to change the support of this. Change the support to that plane instead, and then say okay. Good. All right. So let me extrude this surface. Extrude that, and I'm going to make this thing 400. Good. I'm going to hide the sketch to hide the sketch. Now, on this surface, I will pick a point. So let me go ahead and create a point, wireframe point on surface. For example, on this surface, for example, I selected somewhere here, and then say okay. Now we're going to go to circle, and I say circle center and radius. So the center is here, the point that I created. The radius, I'll make this thing 50 so that you can see the difference. And for the support, I select the surface and full circle. Okay, so we say all right, and look at what happens. The circle was created, but it's created on the normal normal plane, not the normal plane, the tangent plane, whose the normal to the surface is the direction of the plane. Okay, now, if you double click on this one more time, notice that there is an icon here which says projection. So you can take that circle and project it onto the surface. You see that? That circle got projected into the surface. If you unproject it, there he is. Projected. There. Everything that we have done works same way. All these other features work the same way. There is an advanced option here, and that is uh, when you have unprojected that, you can select the axis computation, and there's the axis. This is the direction of the normal to the curve, normal to the surface, which is normal to the tangent. Now, there are other axis directions that you can show to, etc., in case you want to see them. So we did this. You can see that we did this thing by uh, uh, taking as the support a surface. Let's do another one. For example, a circle. Let's say the next one will be the center and a point, for example. Center and a point. Okay. Let me actually do the following. I'm going to delete all this stuff. Delete this stuff. Oops. I didn't want the surface to be deleted. I want to delete these. Actually, let me delete the circle here. Good. Okay. So let me go and take, for example, a point, another point on a surface. Let's say a point like that. You say okay, and create a circle with a center and a point. So for example, for the center, let's select that same point that I did before. For the point, I select this point. This thing out of the way. This point. And for the support, I select that. So what happens is that the circle has been created, but this circle is also not on the surface, but you can project it. The circle has been created. The question is what it has been projected into the tangent plane, which is this. This point has been projected into the tangent plane, and the point that actually the circle is made of is the projection point. That point, the tip of this blue piece, blue line, and that point. So a circle has been drawn. Now, needless to say that if you project this thing, it's going to end up on the surface, but it's not going to go through this point, because the way this point is actually projected on the tangent plane. So, and by the way, this advanced option, when you project things into the surface, is not going to be activated. But if you uncheck this, then you can get the axis showing like that. Okay. All right. So let me cancel that. Let's do another one. Let me create another point on the surface. Another point on the surface, say that point. And for example, when you make a circle, you can have 3 points. 3 points. We can select the 3 points. 1, 2, 3. And needless to say that these 3 points are on the surface. They make a plane, and you can draw the circle that's made of these 3 points. Let me do 2 point and radius. 2 point and radius. Okay. So the 2 points. Let's say that point and this point. Okay. And radius 200. The support is that surface. And let me make the radius smaller, maybe 50. Maybe 60. Yeah. Let's make it 80. Yeah. Okay. So this means that there are two solutions here. For example, if you say here next solution, right now it's let's see which one it is right now. There are two solutions. If you give me 2 points and the radius, okay, you give me 2 points and radius, there are always two solutions to the problem, okay, and you can match between the two solutions, and finally you can project these into the surface, and you're going to get that. The moral of the story is that all the stuff that I've done, although I did it for a flat plane, they're also applicable to surfaces. Okay? And now we're going to move on with the rest of the stuff that we left off. In other words, we stopped, I believe, at bitangent and radius. I'll develop the rest of this presentation for the case where we're making the circle on a planar support and a plane or a planar face, okay? So let's see now. We're dealing with a circle, and let's see what we got here. And we're going to be doing bitangent and radius. Okay, let's see what exactly is needed when it comes to bitangent and radius. So what we need is actually two line elements, two lines, and a radius. Okay, so let me go and select my two, create my two lines. On this horizontal plane, I will sketch one line like that. Okay, exit, and another line on the same plane, not the same sketch though, same plane, like so, exit. All right, so now we're going to go to circle and select bitangent and radius. So for element 1, we select this line. For element 2, we select this line. Now there's a radius 1 millimeter here. That's why it's not going to work. So let's increase this thing to something that let me try 30 millimeter. Preview. Oh yeah, right there. Okay. Let me actually make it maybe more. You can see this. So the situation is like this. You have a circle, and if you do the full circle, actually you can see here the full circle. Full circle is right there. So you have a circle tangent to two lines, or bitangent, and the radius of the circle is specified. Now, obviously, if you make this thing uh, at some point, if you make it too small, it won't work. So right there, you can see that. That's why I got this message. So let me make it bigger. And of course, these are when you flip between the one side and the complement. And this is for trimming. There is a trimming option here. So this one won't let you trim. Yeah, it won't let you trim. See that? It's hidden here. All right, the axis of computation is of course this vertical to the plane that makes these two lines, and center is going to be right there. You can see that. Center is going to be right there, and you can show other axes too in different directions. Very good. Okay, so that takes care of this. Let me get rid of these. Now, this kind of thing could have also been done on a surface, but uh, the, it's kind of hard to interpret what they represent, but it can be done, just like the stuff that I did a few minutes ago. Let me hide this or delete that circle. We are going to the case of bitangent and a point. I did a cleanup here, but I did keep these two lines that happen to be at the same plane. And I'm going to create a point now, a point, let's say on the same plane, but let me use this point. So what I have here is in the same plane XY, I have two lines and a point. Now, remember, the variation of this can be done on a surface too, but we're going to look at things being done on a plane of face, okay, which is this XY plane. Now, go to circle, uh, bitangent, and a point, and you select this line, element one, and this line, or curve. It can be a curve. I'll try it with a curve too. And a point there. This is the point. And a circle is drawn. You might say, well, what circle is this? Here's what happens. The definition of this bitangent and point is that this point is projected into that line, and you get the point down here. You see that? You get the point down here. Let me say, okay. So this point is projected into that line, normal projection, and the curve, the circle, is tangent to these two lines and passes through that projection point. Okay. Okay, so let me actually go ahead and make a slight change here. Let me exit this. Let me go to that sketch. Actually, let me delete that circle first. Let me delete the circle. Okay, I'll go to that line sketch, and instead of this, I will make a spline. So, for example, something like that, and delete that fellow. Okay, I don't know where my point is that I created, but we'll find out. Exit. Okay, right there. Okay, let's try the same thing. A circle, bitangent, and point. All right, bitangent and point. Element one is here. Element two is now curve 2. It was a straight line, and the point is right there. So what happens once again, this point is projected into that curve, and the resulting circle is tangent to the line, to that curve, and passes through that projection point. That's what this thing means. Okay. All right, let's go and get rid of the circle. All right. I don't need this point either. I'm going to delete it or hide it. On the same plane, I will draw either a line or a curve. I'll draw a curve because we're going to be dealing with tritangent thingy. Just think of it there. All right, exit. We go to circle, and the option that we use is tritangent. Okay, tritangent. Element 1, this line, element 2, that line, element 3, that line, and it's going to put a circle that's tangent to all of them. Now, center of it is going to be right there. Okay. And of course, if you want the axis, you can show the axis, y-axis, x-axis like that. And fine, that's a tritangent. And as I said, the variation of this can also be done in support being a surface. Okay. The last thing that you need to do, delete. Okay, the last item is actually center and tangent. So let's see what this thing means. Center and tangent. Center element, we select this line. For tangent curve, we select this, for example. Now the problem is that that 20 millimeter may not be either big enough or maybe too small. So let's make it smaller. Let me make it smaller. We go down. Let me make it maybe 10. Maybe make it bigger. 40. Yeah. Okay. Good. Good. So you can't put anything that you want. Notice that what happened is that the center of the circle is on this line and is tangent to that curve. Okay. Now let's make this thing 41. Work. Yeah. You can see what's going on. Excuse me. Good. That's it. You have done all the cases as promised.